Well, today, this video, I'm combining two ideas. The idea of a three-dimensional space made up of three dimensions, and trying to visualize based on the idea that space-time is supposedly curved, which gives me the idea that the dimensions are all curved, and I want to try to visualize it and take you through my steps, or take you along with my little the steps I'm taking to try to visualize it and whatnot. All right. Well, anyways, so we got a single point with three dimensions, right? We got a single point with one, two, three. Oops. Let me take that back. Three dimensions, right? But what if those dimensions are curved, all of them, based from a single, where they all intersect? Well, it is my assumption that they curve along from this point. Each dimension would curve along, what would it be? Well, okay, I gotta start somewhere. Let me brighten this up a little bit. Doo-doo. Okay. Space-time is curved, which means the dimensions are curved, but how do they curve? Well, given that there are three dimensions, 1, 2, 3, and they're all curved, maybe, how do they curve? Okay, well, let's curve one and see what happens. Let's curve it and keep curving it and keep curving it. Maybe it forms a circle eventually, which, because they're moving, because this is positive in this direction and negative in this direction from the point of zero, or the connecting point of these dimensions. It's positive this way, positive, moving towards negative. And at this point, positives over here and negatives over here, it becomes negative. And that's how, from this point, they attract each other, which potentially they could attract each other in the opposite direction, making what looks like an 8 or infinity, where this point would be positive, this would be negative. Okay, but then there's other dimensions, and not to say that this dimension couldn't do the same thing this way until you have what would look like this, with a tiny little, with it all from here, of loops, or a torus, which is connected at the center, at the midpoint. Okay, that's one. That's one torus. But then there's three dimensions, so you have to take that idea of one continuous torus going around, kind of like this, around this point right here. You kind of see what I'm saying? Where So how do you have to, that's like, if space-time is curved, that means all dimensions are curved. And you know, on a, to kind of go off on a tangent here, the Earth has two poles. Okay. Okay. Which create a magnetic field. Something like this, all the way around the world, which is between those two poles, in a torus type fashion. You know, this is like a cross section. You know, that magnetic field created by those two opposing polarities create a magnetic field. Okay, that would be a torus like this, like one dimension. But you have 3 dimensions, so you have to take that torus and then add one for this dimension, which would be going this way. Okay, equally, perhaps, which is hard to visualize for me, because it would intersect at equal positions in all directions of each dimension to create another torus. It would it would be like with the curve it would represent it 3-dimensionally. It would kind of this circle within a torus. This is hard. We'll create another torus. I mean, how do you represent this 3-dimensionally? Okay, and then this torus is like that, and this torus kind of is intersecting like that. This is another torus here. Kind of. It's hard. I'm not doing too good, but I hope you understand what I'm trying to draw, visualize. And then within that, you would have a third torus, which would kind of be this shape, you know, with its center being like that, like another donut. 3 intersecting donuts. You got this torus. Let's represent it very flatly. Then you have another torus, which I didn't start very well, but going this way. And then you have a third going this way. And then they're all connected at the same point because of the 3 curved dimensions of the 3 dimensions that make up a curved space-time. Okay. This side's positive, this side's positive, and this side's positive. This side is negative, this side is negative, and this side is negative. In an XYZ positive and opposing directional opposing directional dimension. So it kind of creates this torus, or combination of three toruses in a three-dimension, in the third dimension. If you can add, you know, four opposing dimensions relative to the previous three dimensions, you would create four more toruses at the seventh dimensional is what I'm thinking. So what would that look? I'd like to draw that actually in detail with shading, but perhaps I'll do that and add that as a thumbnail at the beginning of the video and perhaps the end. But I also want to mention that as these toruses go around, or actually as the torus is a dimension and another torus is a dimension, but they change polarity in a curved space-time where they go back on themselves. Like this torus would go back on itself because it's attracted to its opposite, and they would change places where positive would become negative and negative would become positive. So a torus like this is kind of split at the point in which, say, these dimensions where they're going around at where they reverse polarity, right? Or, yeah, because in a curved space-time, right? You have this torus and it's moving this way positively, and then from this point, center point, and then once it reaches this outermost point, this division of the torus, it moves back around and changes to a negative polarity, because it's curved because it's attracted to itself in a way, this dimension, which creates a torus. Okay, I'm going to try to draw this out using, shading in a three-dimensional kind of thing. I'm going to try that. Hopefully it won't take too long before I, lose interest. Okay, well, later. I'm going to stop now.